Okay, back again. So the title of the first lecture is the Maritime Network and the Global Fleet Structure. And firstly, we have an introduction and the goal of this presentation. Then we explore the Maritime Network, an introduction of how the network works and what are the interactions between the industries, the structure of the network, the various stakeholders within it, and also the globalization and the maritime market, how those two interact and how the globalization drives the maritime trade and backwards. Then we will have a look at the global fleet structure, more specifically the fleet size and up to date, the fleet composition, the various ship types that are available at the moment and the ones that are completed for the future, the operational productivity of the fleet, and the current fleet overcapacity, which is a main subject of the time. Then we will have a look at the ownership and age of the world fleet, some statistics up to date. And lastly, we will look at the modeling of maritime transport, various state-of-the-art solutions that exist at the moment in the way of modeling maritime transport, and some hints on the boundary conditions of maritime transport modeling. So firstly, the goal of this presentation is to introduce the audience to the overall structure of the global maritime network and further understand the fleet structure and their interdependencies. Firstly, we will look at the global nexus that maritime services and operations create. While at the later part, we will focus on the supply side dynamics of the world industry, and mainly meaning the actual fleet and the fleet composition. So to start with, this picture presents the footprint of the maritime transport, of commercial maritime transport actually, and it encompasses the routes around the globe that actually represent the movement of cargo. You can see the density of the routes and the trading around the globe. It is well known that maritime transport nowadays, and not only nowadays, but from a long time ago, it's the backbone of international trade. It's the most efficient way of transporting goods from in long distances and cost effectively, and is a key engine for driving globalization. Around 80% of the global trade by volume is done by maritime transport, and around 70% by value is carried overseas. Of course, the shares are even greater for the developing countries. So now, in order to see how shipping works, we need to distinguish the different markets that are within this great market. Firstly, we can say that if we isolate shipping from global trade, we can consider that it's constituted from three different sub-markets. Firstly is the freight market, which the freight market is of course the outcome of shipping trade. And then is the sale and purchase market trades, which is actually the sale and purchase of vessels. Within that is, of course, the new building market, where new vessels come into the market. And lastly is the demolition market, where vessels go out of the trading game. So all those three sub-markets are very closely correlated, and they are linked with supply and demand, and they're also linked with the cash flows, because cash flows are coming from the freight market, then also cash flows are coming from sale and purchase of vessels, and also from the demolition of vessels. Of course, the main cash inflow comes from the freight revenue, which of course is volatile and depends on the global trade growth and the freight movement. Also, the demolition market contributes a lot into cash inflow, especially those days where there is a great overcapacity of fleet. And while the new building market is doing the reverse, money are leaving the shipping market and going to shipyards. So these three sub-markets, and actually the contribution of cash flow between them, actually constitute the shipping market cycles. So in order to understand in more depth the concept behind shipping, we have conceptualized what is called the double triangle, which represents the core of shipping activity, and it's also the ground for other satellite services that exist around it. So as you can see in the upper part, there's of the inverted triangle are on one side the ship owners, the other side the ship managers. They both represent the supply side of the market, while at the latter end of the triangle are the charterers, where they represent the demand side of the market. Now between them, of course, you can see that in another triangle are the brokers, which actually they match the supply with the demand. So this is actually the core of the shipping activity, and around this triangle, all the other services go. So this is a representation of how the nexus of maritime services grows around the core of the shipping business. So the triangle that we presented before, which is matching the supply and the demand, and all the other services that go around it. So, for example, the maritime consultants, shipyards, ship repairs, and then we have suppliers and spare part suppliers for the actual vessels. We have the educational institutes and research and development institutes as well. And then we have, of course, the financial institutes and banks that they are providing the cash flows for the ship owners to do their business. Then we have the regulatory bodies and the classification societies that they are moving the regulatory framework around shipping. And of course, insurance and P&I clubs and law firms that they are also grow around this business and help in the everyday work. So another representation of what we're trying to explain here is one of the agents or stakeholders that exist in the market. So in the lower part, there are of course the demand drivers, as we previously said, which are the freight forwarders. We have the industries, the construction, the actual manufacturing or mining industries that they are in demand of raw materials, and also the final consumers. For example, in container trade, the final consumers are the ones that play the more severe role in demand, while in bulk transport or oil transport is the industries. In the middle of the diagram, we have, of course, the shipping operations, which are the stakeholders relevant to the shipping operations. And as we previously described, it can be the shipyards, the ship financiers, the flag states, the ship owners, or the management companies, or even the port agents and the bunker supplies that are involved in everyday operations of the ships. And on the upper part of the graph, we have the regulatory framework, which is actually kind of bounds the whole picture, because it is, let's say, it regulates, and it is a framework where all shipping activities need to operate within this framework. So because they need to comply with specific regulations, and which are designated by member states or the IMO or international bodies in flag states. So here we have an example of, let's say, a typical maritime network. So we usually have one of the branches of the network is the shipping operations, and then we have the maritime services, and then we have the maritime industry, which is separate from that. So in shipping, we have usually operators, we have managers and agents of vessels, and we also have ship management companies. In the branch of maritime services, we have, of course, the marine consultants, naval architects, we have S&P brokers, chartering brokers, we have protection and indemnity clubs, we have the manning agents for the crew, we have the maritime lawyers, of course, freight forwarders, all kinds of business consultants that exist in the shipping business. We have banking and finance, and of course the classification societies again. And lastly, we have the maritime industry, which constitutes of mostly of, let's say, manufacturing and engineering. So it's suppliers of spare parts for the operation of vessels. We have the shipyards and the ship repair yards that are there for the life cycle management of the vessel. And then we have the marine equipment manufacturers, and also the machinery and engine repairs, that they're also a very important role in the operation of the ships. So this is a typical composition of the maritime network, and we can see this is coming from an actual maritime cluster, let's say, and we can see the composition of it, and in what percentage each of these stakeholders exist in this cluster. Of course, it is this varies very much from country to country. So, for example, in Northern Europe, maritime clusters or networks have a strong presence of the offshore industry, for example, or they have a very strong presence of special activities like dredging, or, for example, in London, they have a very strong presence of financial institutes and P&I clubs. While, for example, here in Greece, there's a more concentration of shipping operators. So there's a different presence in its maritime network. However, operators mainly dominate these networks, maritime operators, and also let's say machinery and spare parts suppliers dominate the networks because they are essential for the operation of the vessels. While we see that this composition presented in the graph constitutes a complete maritime cluster. The structure, as we said before, is kind of unified. However, it varies according to the competitive advantage of each country, which also depends on the geographical area of the country. For example, in the Middle East, maybe there are maritime networks that they give more focus on the oil and offshore industry, while in Asia there are maritime networks that they give focus on the shipbuilding business. So now to the maritime network and globalization. Well, according to the theory of Potter about the maritime network, about generally business networks, firms are considered to be a value chain composed of primary and support activities. And since they're trying to focus on their primary activities, they need to maintain their competitive advantages. So they are facing the necessity to optimize their support activities, meaning logistic services or shipping movements or operations. So they need to reduce the trade barriers and evolve the transportation technology in order to create global supply chains. And here is where maritime transport plays a key role because it has these inherent advantages of reducing the boundaries between long-distance trading. So there are, again, as we have explained, there are various stakeholders within this business, and there are various nations worldwide that they have used the opportunity. They have used the opportunity to have this competitive advantage, and they have become global leaders in some specific factors within maritime transport. So what is driving globalization? Well, actually globalization is coming from the fact that when the cost of production in a place is greater than the cost of production at another place plus the cost of transportation of this product, then it is and if the second place is of course remotely located, then this triggers the actual trading pattern and also the globalization, because if the production cost in a remote place is much lower, so that it can actually, together with the transportation cost, it can be given at a lower price than the local product, then trading becomes a very profitable action. So shipping and globalization have a symbiotic relationship, we can say, because in one hand, globalization has increased the demands for maritime shipping, while maritime shipping has, let's say, enabled globalization through its trading actions. So we can say that globalization is motivated due to the recognition that resources and goods are not always collocated with the populations that desire them. And this has a lot to do with trade growth and also the trends of consumption that vary worldwide. So here we can see in the graph we can see a possible forecast for the sea trade scenario. It grows about 2.4% per annum, and we can see a projection up to 2050. And it's a general rule that sea trade always has a growing it has a growing demand. So now the most, let's say, typical, the most typical maritime trade for globalization is container trading. We can see here how in the graph we can see the trend between three different modes of transport and shipping. We have the liquid bulk in the blue line, we have the dry bulk in the red line, and we can see how the containerized cargo is in the black line has grown over the last few years. So container shipping represents a significant increase in global transport of finished and semi-finished products, of course from regions with inexpensive skilled labor to consumer markets. This means that because if we consider that through container shipping we're shipping consumer goods, for example, let's say PCs or AC units and or electrical units that we use every day. So these units are manufactured in inexpensive labor countries, like for example in the Far East, and then they are shipped to the Western world because the transport cost can be put within the marginal cost of the product. This is also, we can see that due to the growing demand of consumer goods in the Western world, and we can see that there is a fact that the containerized cargo has outpaced other bulk cargo, and this shows the impact of globalized trade involving consumer goods and international labor. So now, after let's say looking in some detail the way the maritime network works and the way shipping trade works, we will move forward to the global fleet structure. The world fleet is composed by various, let's say, ship types, type of vessels, and here in the graph you can see that we have, for example, oil tankers, we have bulk carriers, we have general cargo vessels, container ships, we have the liquefied gas carriers, chemical carriers, offshore supply vessels. We have the ferries and RoPax vessels, and of course we have other type of vessels that are more, let's say, dedicated to specific works. So the world reported fleet counts of about 43,000 ships approximately, and it has an average increase the latest years of 9.2% annually, and the average age is about 19 years old. This age is actually dropping the last few years through new deliveries and a lot of demolitions taking place at the moment. So this composition that we see of the world fleet actually reflects the demand of seaborne trade of different commodities, whether it is bulk cargo, it is containers, or it is oil. We can, as we previously said, we can see the great increase in the containerized fleet, that it was accounting for 1.6% in 1980, and now it's representing more than 13% of the world fleet. It is evident from the graph that bulk carriers are, let's say, accounting for the biggest part of the world fleet, and followed by oil tankers. So this is the main bulk commodities transporters, and also they're driven by industrial processes. And then they're followed by container ships that, as we said, they have very much increased the latest years, and also from general cargo ships. And of course, the other ship types are following with smaller parts of the fleet. So we can say that the composition of the world fleet can be modeled in four main categories. We have the dry cargo, we have tankers, passenger ships, and then we have also specialized ships. So these both main categories represent, let's say, more or less represent the global fleet. So the dry cargo composes of bulk carriers, multi-purpose vessels, containers, ro-ro vessels, conro, and also reefer vessels, which are not really used that much anymore. Then we have tankers. Tankers are composed of crude carriers. We have product carriers, which carry different kinds of cargo. We have chemical carriers, which also have a great variety of cargo, from vegetable oils to chemical cargoes. And then we have the liquefied natural gas carriers, which are also gaining in demand the last few years, and also through the development of natural gas as a prime mover in also land use and also in shipping as well. Then the passenger ships, they mainly compose of ferries, whether they're day ferries or night ferries or cruising ferries. And then we have the cruise ships. The cruise ship fleet has been developing steadily the last years, and mainly from ships built in Europe, and also from 2 or 3 main operators worldwide. And lastly, we have the RoPax vessels, which are actually serving the domestic demand of countries for short sea shipping, for transporting passengers and goods into short distances. Lastly, we have the specialized ships. They compose of tugs, for example. Tugs can be either port tugs, port assistance tugs. They can be anchor handling tugs. They can be tugs for driving the vessels into bigger, let's say, ports. And they can even have more specialized tugs for doing multi-purpose works. Then we have the offshore supply vessels. They have become quite popular the last decade for assisting offshore operations. There are many variations of offshore supply vessels. They can do anchor handling jobs while they're near a drilling platform. They can also carry personnel to the platforms, or they can they have some special, for example, tanks for carrying cement to the platforms. Then we have, of course, the rigs, the offshore platforms, and fishing vessels is part of the specialized ships. There's a small fleet of big steel fishing vessels, but there's a very big fleet of smaller fishing vessels, especially in Europe. Let's say that specialized and new technology fishing vessels are very rare nowadays, but there is, let's say, a trend nowadays to go for new technologies and new fishing vessel types, especially in northern countries where fishing is in remote areas and in hard environments. Then we have dredgers, part of the specialized ships. Dredgers do not really exist in many places. The main country that employs a fleet of dredgers is, for example, Holland. They use a lot of dredgers for opening canals and also opening the routes to their ports. And also, it is the same for the countries that in the North Sea, where the tide changes the depth of the ports. And of course, the drill ships. Drill ships are used to either in order to drill and retain oil or gas from underneath, and they can also store and the cargo to other vessels. So, as I said before, regarding the dry cargo vessels, we can see here the example of various types of vessels. We have the bulk carriers, the multi-purpose vessels. As we said, you can see a reefer vessel, which is not anymore type of vessel that is preferred or used. There are existing reefer vessels at the moment in the market, but there are no new deliveries of reefer vessels because at the moment refrigerated cargo is mostly moved by container vessels that they can also handle reefer containers. You can see also a new design of a RoRo vessel with different design of the bridge and cargo deck coming, driving beneath the bridge, and typical container vessels. So regarding tankers, as we said, we have of course, we have the very big and also the smaller types. Very big, as the first picture is VLCC vessel, and then we have Suezmax, we have Aframax, and we have also product carriers and chemical carriers, and of course the liquefied natural gas carriers, and they have become more popular. And chemical carriers are also a big, substantial part of the fleet, but they don't represent the big tonnage because they're usually small vessels. They're about 100 to 120 meters long, and they carry a variety of cargo from, let's say, vegetable oil to very specialized chemicals used in different industries. And they usually do short routes, and between ports. Then we go to passenger ships. As we said, we have the ferries, cruise ships, and RoPax vessels. You can see an example of RoPax vessels. They're mainly, as we said, they're mainly used for transporting passengers and also cargo goods, but wheel cargo, let's say either passenger cars or trailers. There has been a substantial growth of the European mainly fleet of RoPax vessels the last decade, and there has been a trend of bigger vessels with greater comfort and accommodation, mainly called cruise ferries, for example, which they have been used with, they have been delivered with high speeds and very big engines for that reason. This has led to nowadays this kind of vessels are not anymore let's say sustainable, and there's been a change of trend. People cannot afford anymore to operators, they cannot afford to move very big ships with very high speeds. They have started reducing speeds, and they are looking into vessels with less power and smaller capacities. Regarding cruise ships, as we said, they are The most of them they are constructed in Europe. Mainly 90% of the cruise ships worldwide are constructed in Europe. They are it's not a very fragmented sector because there are 2 or 3 global players, and they're actually dominating the market. So, and what we discussed before, the specialized ships, you can see some offshore supply vessels and some smaller tugs, and you can also see a heavy lift vessel carrying a rig, which is nowadays heavy lift vessels are used more and more, and there are even new designs to carry more capacity, and because there is a lot of demand of carrying specialized cargo, especially, for example, in countries where the offshore industry is very active, let's say in Singapore or Brazil. Nowadays, such vessels are becoming very popular. And you can also see a modern fishing vessel for Northern Sea operations. So, what are the trends behind the development of the world fleet? Nowadays, operators have been ordering for economies of scale and also for energy efficiency. Well, there is a must that for reducing fuel efficiency nowadays, having in mind the price of oil. And the classic approach to enhance this fuel efficiency is to increase the vessel size in order to achieve greater economies of scale. And this is what was in the mind of operators, but this comes with an assumption that their ships will be full during the transport work. So as the industry was recovering from or trying to recover from the economic crisis in 2011, many orders and deliveries of record-breaking size came into place in various cargo vessel categories. Taking this in consideration, there is a need to generate enough cargo for these very large vessels that they were actually delivered. It gives some space for a consolidation between shipping lines, and this can create, for example, mergers and acquisitions, and in order to strengthen their operation, and in order to pursue, let's say, a more collective way of transporting goods within the large vessels that they have now acquired. So then the new trend rises that they came in place after 2011. As we said, the operators having in mind to order for economies of scale and energy efficiency. Very substantial examples for this are for example, the Maersk Tripoli container vessels, 400 meters long by 59 meters wide. Very good example. Designing for economies of scale. And we also have the same pattern in, for example, in Wilhelmsen Roros, 259 by 32 meters long is the biggest Roro vessel in the world. And also in the dry bulk market, where we have the Vailmax size, mainly designed for cargo routes between China and Brazil for iron ore cargo. And it's approximately 360 by 66 meters wide. So these are some examples of vessels that they have been ordered with assuming that they will be they will have a transport work and they will gain from economies of scale. So now the fleet development. In 2009, the fleet consisted of approximately 1.19 billion deadweight tons, and in 2008 we have 1.40 billion deadweight tons. This is a growth of approximately 17% in 2 years. So a lot of ordering took place before 2009, and a lot of completions came into the market during the period of 2009 and 2011. Oil tankers had a yearly increase of 5.5%, and while bulk carriers they had an increase of 16.5% respectively. And the tonnage of dry bulk carriers, due to a lot of ordering, has continued to exceed the tonnage of oil tankers after 2009. As we have indicated before, container ships fleet has substantially increased, and this reflects the weight sharing manufactured goods that need to be transported around the globe. You can also this represented in the graph shown here. You can see in the first part that in the blue share is the oil tankers. So it's the development of oil tankers through from 1980s to 2012. You can see that there is a growing trend, but there is a more substantial growing trend for dry bulk carriers above it, and also for container vessels, which they started growing after 2010 substantially. For general cargo vessels, the demand is the development is more or less similar through the years, and we can also say that it's dropping a bit because of movement of cargo through generalized container vessels or multi-purpose dry bulk carriers. So if we have a look at its different category, here we have some data regarding crude oil tankers. So about 6.5 million deadweight was scrapped in 2012, but still this is not enough, as the market says, to overcome the overcapacity that is evident at the moment. So this trend of scrapping older vessels has now shifted in scrapping even vessels that we wouldn't think of taking to the scrapyard a few years ago, due to the very low freight rates and the need for cash flow from demolition of the ships. So the average scrapping age is falling, and at the moment it's about 15 years old vessels are going to the scrapyard. Something that operators would not consider a few years ago. There is a continually growing interest on MR product tankers, and also a big interest in gas carriers. So the technology for gas carriers has evolved and it's now very mature, and operators are seeing great future demand for LNG, and this is why they're putting more orders for LNG carriers and LPG carriers. So you can see there were 20 LNG and 40 LPG carriers contracted during 2012. In the graph, you can see the actual fluctuation of the fleet development, the crude oil tanker fleet development, and which has started growing immensely from 2002, and with some up and downs, and keeping a relatively good growth through 2012. Now the fleet development of bulk carriers, we have a much bigger scrapping deadweight here, 35 million deadweight scrapped in 2012. And we have 120 million deadweight delivered. So the overcapacity is much greater than the crude oil tanker fleet, and this is creating a bigger problem, and it's pressing the freight rates even lower than before than the crude oil tankers. So this is why also we had a very moderate growth during 2013. With some potential improvement after 2014, because we now see more and more vessels going for scrapping, and more, let's say, strict regulations are imposed by various countries, but they're actually declining very old or vessels that are not in good condition in their ports. So this is putting more pressure in scrapping the older tonnage and utilizing the new vessels that they're now in the water and they're waiting to be worked. So you can see in the graph how this substantial increase in the fleet development has started from let's say 2002, 2004 through 2012, and now we have a bit of decline after 2012, and we are still in this phase. In 2011 we had a very big, let's say, delivery peak. A lot of vessels hit the water. So this is what is actually also presented here in the graph. And then we have the development of container vessels. We have generally a continuous growth of the fleet. However, we have a very consolidated market here. I mean, this means that about 20 companies worldwide control 85% of the fleet. So we have the big players like Maersk or COSCO and Noel, but they control the biggest percentage of the fleet. And then we have, of course, very small operators that they have mostly utilize feeder container vessels to move from smaller ports to short sea shipping mainly. But the main routes are dominated by the big companies. So the first half of 2012 saw about 800,000 TEU delivered, and this was a big increase relative to the previous years. And we can see that companies, as for example we saw before from Maersk, they're going to bigger vessels, and even companies that they were not considering of investing in such big vessels, they are now ordering for greater capacities. So further to the development of the fleet, a substantial role of the market is actually the productivity of the vessels, operational productivity of the vessels. It's actually it means how productive each vessel can be annually, how much cargo will it trade and deliver, and how much it will be utilized. So we can see from statistics that the average ship in 2008, for example, average ship was fully loaded about 7.7 times during the year, and about 31.6 ton miles per deadweight were performed during this year. So this means that the average carrying capacity transported for 1 ton of cargo over a distance of 31 of 600,000 nautical miles. In 2007, it was 87 miles per day. Operators put a lot of interest in the operational productivity, and this is what they account when they are forecasting for the next year operations. So now a bit more detail for the fleet of overcapacity. Even in 2007, the overcapacity for oil tankers and dry bulk carriers stood at 12.1 million deadweight, so greater than the previous year, and now it is even greater. And this means that the surplus of tonnage as a percentage of the total fleet stood about 1.1%. The capacity in this the same as far as it concerns the container shipping growth. It outstripped the growth of containerized trade, and overcapacity came during 2007. However, demand from trading in the container market came back after 2007, and the overcapacity stood at very lower levels than before. So at the end of 2011, almost 1% of the world fleet stood idle with no transport work, and the highest idle shares were reported for LNG tankers, 1.9%, and also for the Ro-Ro fleet, 1.7%. This was due, for example, the LNG tankers, they're highly dependent of development works in LNG infrastructures. So 2011 was a year where many LNG ports and infrastructure works were delayed. So we can see that a great amount of LNG tankers stood idle because they could not trade in the spot market. They were more related to the big LNG infrastructure trading. So the same happened with the Ro-Ro fleet, and this is possibly a decline in global global trade due to the economic downturn, especially felt in 2011. So due to the discussed overcapacity and the very high fuel consumptions, all trade carriers now they aim of reducing their fuel consumption by and also the general overcapacity in the market by reducing their operational speeds. So, however, most of them they have incurred very important financial losses due to this continued oversupply of tonnage over these years. We can see that even container carriers, they're now reducing speeds. Container vessels are designed very specifically for high transport speeds, and now they're doing a different operational scheduling in order to reduce the speeds and save in fuel consumption. Making investment in new and bigger ships and more energy efficient vessels, it makes sense for a company level. However, bigger ships further add to the overcapacity, to the world overcapacity, and this is keeping the freight rates down. So you can see the trends in the overcapacity we have discussed, and you can see that tankers are dominating the overcapacity during 2010, and also bulk carriers as well. So it's mainly those two type of vessels transporting the main bulk cargoes that they have a substantial problem in overcapacity. So now we'll go to the ownership of the world merchant fleet. So we can see here the top 10 countries that control the world's largest fleet. And these top 10 countries together control about 70% of the world's fleet. And let's say that 4 of them are from the Far East, while 5 come from Europe and 1 from the Americas. So from the, let's say, more developed countries, while we have none of them from Africa or Oceania. So we can see that we have Greece in the first position with let's say less vessels than the second one, than Japan or Germany, but much greater deadweight tonnage because they've been investing in more bigger ships, bulk carriers and oil tankers. However, the deadweight tonnage, the high deadweight tonnage of Greek ownership comes from mainly from oil tankers and VLCC tankers, for example. So in terms of deadweight, this accounts for 16% of the world of the total world GDP. And then we can see that we have Japan, Germany, China is moving upwards, and it is expected that, let's say, but by 2030, that China will be heading near Japan and Greece in terms of deadweight of tonnage, and also Singapore is also at the bottom of the list, but they're highly investing in new vessels, and also they are also attracting a lot of shipping business in Singapore, and this will potentially increase the number of vessels registered in Singapore, and also the deadweight tonnage percentage of the world. So here we can see the relative to the top 10 countries that we discussed before for the ship ownership. We have for these top 10 countries, we have an average age of 15.5 years, and we can see how the average age trend for each country develops in this graph. So moving on, we can also we can see in this next graph the development of world fleet in terms of number of ships and in terms of GD, and also in terms of deadweight. In the blue line you can see the number of ships, while in the red the tonnage, and the latest one, the green one, the deadweight. You can see that the deadweight is much higher than the number of ships, and you can see that the deadweight is actually increasing substantially from 2004 and after, where companies are going for bigger ships and looking for economies of scale of transport modes. Now, further to the ownership of the fleet is the registration of ships. So the year 2011, where a lot of deliveries were put forward, and we saw a substantial increase in the use of open registries. So open registers are flag states that they actually provide registration of ships in favorable conditions and also tax conditions, like Liberia or Marshall Islands or Panama, for example. So 83% of the tonnage delivered in 2011 was registered abroad, meaning from a different flag state than the flag state of the owner company. And 72% of the world tonnage in total is registered under a foreign flag. So you can also see this in the graph. For example, we have with the gray color, we have the foreign owners and the national owners with the blue color. So you can see that in Liberia, there are only registered foreign owners, for example. There's no domestic ownership. I mean, all the open registers, like Panama, Marshall Islands, and also Bahamas and Malta, the Isle of Man. And then you can see that this trend is changing as we are moving through states, through countries that they also have a share of ownership. For example, you can see that in Germany, that they're mostly national owners, that they're registered in the flag state. Further to that, the last few years there has been a substantial increase in registering in countries like Hong Kong, China and the Marshall Islands. And this is due to also a big domestic increase in ownership in China and the Far East. Small operators are becoming bigger, and also the state is the state in China, for example, is providing aid for taking ownership of vessels that are delivered from Chinese yards, and also for registering these vessels in the Chinese flag state. So now we move forward to the maritime transport modeling. So a question: why is there a need for maritime transport modeling? We need to address the fact if there will be, what will be the future for the shipping industry, what will be the potential for trade growth, what is the future for the users of the shipping industry, operators, suppliers, and cargo suppliers, and also what is the potential, what are the potential global trade patterns, what will change, especially from developing countries, that they will produce more and they will also consume more, and this will probably change the pattern of trading. And which are the best policies to control negative externalities from shipping? In order to address maritime transport modeling, we need to have in mind some gravity factors. First of all is the geographical extent, which means the continents, the nations, and the ports involved in the maritime transport. We need to have in mind which of them are producing, which of them are supplying, and which of them are consuming, who are developing and who are in development. Then we need to take in mind the fleet extent. We need to, as we have seen in this presentation, we need to know exactly the ship types and the ship sizes, what exists and what are the trends, and what is the market wants, and which are the actual routes and the commodities that they transport. So And lastly, we need to know the operational extent. Will it be a seasonal, annually, or a daily operational forecast in order to do our modeling. So these are some boundaries that we need to consider before we go in modeling the maritime transport trade. So some important factors that and trends that they're at the moment reshaping the industry's future, and they're actually altering the global seaborne trade patterns, are first of all the climate change. So climate change is becoming more evident, and also there's societal pressure and also pressure from governments and regulators to address the environmental impact of shipping. Then there's also the shift in global economic influence and also the emerging markets. So we have developing countries such as India or Brazil that they are starting to consume more, and also they are producing products that they want to export. So this creates a shift in the global economic patterns. Another important factor that nowadays is maritime piracy. It needs to be taken into account because it affects substantially also the trading routes and also the safety of the operations, and it needs to be taken into account while forecasting a specific transport activity. And also there is a growing momentum of sustainable imperatives. This means that it's also connected to the climate change. So sustainability is a key factor at the moment. And most of the nations, US and also the European Union and the IMO are considering sustainability as the key factor of the future of shipping. And this comes through regulations, regulations for reducing the fuel emissions or for the impact of ships to sea waters or in general pollution. And now we can see that there is a way of modeling, maritime transport modeling, conceptual model for that. So firstly, we take into consideration the exogenous drivers. So these are coming from external, let's say, triggers, and these are the consumption. It's coming from population. It's coming from the wealth of the population. Then we have, of course, the production, natural resources, and manufacturing. We have the fuel, which is the price of the fuel, the fluctuating price of the fuel, and also the availability, which is a big factor in the price. And then we have the policy, which comes with regulations and with global regulations that are impacting shipping. So these are the external drivers that they feed some triggers into global transport. Within this model, we can see that firstly we have the transport demand, and transport demand is coming from the actual freight or from the passengers that they need to be carried. Then this is connected to the routes and the logistics of the trade. So we need to allocate which mode or which ship type will carry the cargo, and we need to allocate the routes from one port to another, or which other modes need to be involved. Maybe we need to have intermodality, let's say ship to train or pipeline to a ship. And after allocating this, we need to define the logistic model, shipping logistic model. where we have the interaction between these sub modules. So after defining the transport demand and also defining the routes and the logistics, we need to define the ships and the technology. So we have actually selected during the, let's say, the logistic model, the type of ship and the type of cargo that we want to transport, and we need now to define what are the existing technologies, if the current ships can address this transport need, or if we need to look for something else. So this goes to the ship stock model. It means that there is a model that represents the ships available in the market. And then this is connected, of course, also to the port model, where we have all the possible ports which are available and need to be matched with the cargo and the ships, the actual demand for transport. So then we need to look into more technical details like the loading of the ship, the speed, the distance, and all these are fed into the ship model, and they create this branch of ship and technology in our model, which is connected to the previous one, the routes and the transport demand. So as a general modeling structure, we have the energy supply that comes from all these modes that we described before. And through that we can assess the emissions and the cost of the transport. So this can give us feedback that can go back to the system, and there can be some fine-tuning of different parameters and features of the model. Now I think we're near the end of the presentation, and this is regarding the modeling of maritime transport. This is another approach of modeling. So it's called the agent-based modeling of the shipping market. You can see that there is we have different sectors within the maritime network that we described in the beginning. So there's shipping, ship brokers, and consultants, and then there is governmental bodies, associations, the port authorities, etc. So between them there are inter-sector networking, and there is of course knowledge flow and knowledge circulation between these different stakeholders in the market. So this can be modeled by what's it called, agents. So each body, each firm, or each sector can be modeled as an agent in a computational model that has some particular behavior. So, and then we can through that create a simulation where each agent acts upon its behaviors, and it takes feedback from the other agents, and creates a simulation of the trading patterns. An example of this we can see in this picture. So this is a general model based on the previous graph, where we have modeled each agent is actually representing a firm. Either different colors are for different sectors. So let's say the red agents are from the ship operators. So we have modeled the behaviors and the knowledge that is flowing between them. So for example, operators demand information from brokers, or then they demand, so spare suppliers demand information from the ship operators, consultants demand from other stakeholders. So based on that, let's say that the probabilistic map is of interaction is programmed behind these behaviors, and upon that each agent interacts with each other. So this model runs in a simulation, and we can see the different patterns, and we can see which sectors interact more, and what are the outcomes of their interaction. So thank you very much for your attention. If you have any questions.
So no questions? So we thank you for watching. We will continue with the next left topic in about 20 minutes. Okay? Thank you.